right, so for F, the word equation that we're given is zinc plus tin 2 chloride react to produce zinc chloride and tin. So our first step, we're going to write down our skeleton equation. So I've got zinc, and I've got tin 2 chloride. So when I look up tin, his symbol is capital S, little n, and because that's stock system 2, that means it's the 2 plus cation. And with the chloride, he is the capital C, little l, so that's chloride. Crisscross to get my neutral compound, which in this case is going to be 1 tin cation and 2 chloride ions. And it's going to react to produce zinc chloride. Zinc makes the 2 plus cation. Chloride, we already know, is the -1 ion. Crisscross, my neutral compound is 1 zinc cation and 2 chloride ions. And then I've got tin metal all by himself. So when I do my diagram, I'm going to give each element its own color, and we don't have any polyatomic ions here to worry about, so I'm going to give zinc green. So I've got zinc all by himself. Then I've got tin chloride, and I'm going to make tin purple, or sorry, blue, and I'm going to make chlorine purple, and I've got 2 chlorines paired up there with tin. On my product side, I've got zinc, and zinc I made green, so there's 1 zinc, and he's paired up with 2 chlorines, so I'm going to have a nice purple circle there for chlorine, another purple circle there for chlorine, so I've got 2 of them. And then we've got tin all by himself. So before I write my balanced equation, I'm going to double check my colors, see do I actually have it balanced. So I've got 1 zinc on my reactant side, 1 zinc on my product side. I've got 1 tin, blue tin on my reactant side, 1 tin on my product side. So tin is balanced. My chlorine, I've got 2 chlorines on my reactant side, I've got 2 reactants on my product side. So in this particular case, my skeleton equation also happens to be the balanced chemical equation. I have 1 zinc reacts with 1 tin 2 chloride to produce 1 zinc chloride and 1 tin. And note, it really has to do with the fact that the tin 2 plus cation has the exact same charge as a zinc 2 positive cation. And that leads a lot to why it was balanced that way. So let's do one more example here. So G, we've got copper plus silver nitrate reacts to produce copper 2 nitrate and silver. So this is very similar to that Christmas tree video that we took a look at. So first step, drawing out my skeleton equation. So with my copper, symbol for copper is capital capital C, little u. Reacts with silver nitrate. So silver, his ion is Ag positive, and nitrate is NO3 negative. Crisscross, I need 1 of each. And I'm going to have copper 2 nitrate. Now copper 2, that stock system Roman numeral tells me that the copper ion that we have is the 2 positive ion. and I've got it paired with my nitrate. And so when I do my crisscross to get my neutral compound, I've got 1 copper cation, and I'm going to have 2 of the nitrate ions. And then I'm going to have silver by himself. So when I take a look at this guy, I've got a polyatomic ion, that nitrate. And so I want to treat nitrate as a unit. So I'm only going to do 1 color to represent nitrate. So let's do our diagrams. So copper, I'm going to make copper green. And I've got 1 copper there as a reactant. For my other reactor, silver nitrate, I'm going to make silver blue. And I'm going to make nitrate purple. And I'm just going to make him a really big purple circle to represent that he actually is quite a big polyatomic ion there. On my product side, I've got a green copper ion, and then I've got 2 of the nitrate ions there. So I'm going to have 1 big purple one there, and there's his second purple guy there to go with my copper 2 nitrate. So I've got 1 copper ion, and I've got the 2 nitrate ions. And then I've got silver all by him lonesome off to the side there. So now I want to take a look at my diagrams and use the colors to help me do my balancing. So when I look at copper, I've got 1 green, 1 green, he's balanced. Now when it comes to my silver, I can see I've got 1 blue on the reactant side, 1 blue on the product side. He's balanced. But I know that when I got those polyatomic ions in there, it's almost easier when it comes to balancing to balance those guys first. So if I take a look at my nitrate, I've got 1 on the reactant side, but I actually got 2 on the product side. So that means I need to add another silver nitrate. So that means I need another blue circle for silver, and I need another big purple circle for a nitrate. And so now I've got my nitrate is balanced, but I now have 2 of the silver on my reactant side. So that means I'm going to need to add another silver to my product. And when I take a look at how many diagrams that I've got there, because I now have my green copper is balanced, my blue silver is balanced, and my purple nitrates are also balanced now. So I drew 1 copper, I drew 2 of my silver nitrate, I drew 1 of my copper 2 nitrate, and I drew 2 of my silver. And the number that I drew is the coefficient I'm going to have for my balanced equation. So that means I'm going to have 1 copper. And remember, we don't actually draw in or write in the 1. We know that we have 1 by just having that symbol there. I drew 2 silver nitrate, so that means I need a coefficient of 2. And that reacts to produce, and I only drew 1 of my copper 2 nitrate. And I drew 2 of my silver.